So hello guys, today I'm just going to do a video on sentiment analysis, and what I just want to say is that sentiment analysis is just an example of natural language processing, and natural language processing, or NLP, is a branch of artificial intelligence that enables machines to understand, interpret, and generate human language. And basically, narrowing down to sentiment analysis is a common application of NLP, and it involves analyzing text, like reviews or comments in shows or in social media, those posts, to determine the writer's attitude or the emotional tone of the customer, the user, whether the review, the comment is positive, negative, or neutral. And this is important in helping businesses to be able to understand their customer opinions and improve on decision making. And so, without much ado, today I'm just going to pass through some code here that I've done for us to be able to do sentiment analysis, and it's just here. Yes. Even as it loads, I hope so you have your VS Code ready. And what you're going to start with, this is a bit is the same, but it's a bit advanced, because after I had trained a model of sentiment analysis here, this one. So I just came and tried to test it and to see how efficient it was. And right away, to start with, we have to install these libraries. They're very important. And as you guys know, pandas is a Python data frame that help us to handle tabular data like CSV. And we as because for me, I've just uploaded I'll use my CSV file here called sentiment. And so the second library is sklearn model selection import test spread. This is important to help us to split data into training and test. The other one is for feature extraction. This method, the feature called the TF ID vectorizer. This is important to help us convert text into numerical features based on word frequency and important, because in machine learning you find we use numerical values solely for the noise in the background. So whenever you have text, you have to convert it back to assign it a numerical value, a unique numerical value. So the second one is the linear model from sklearn. The linear model import logistic regression. This is now the algorithm that we're going to use to in model classification. This pre-processing input global encoder. This one is just going to help us to this basically focus on doing the no labeling the comment or the text, to label it maybe as positive or neutral or negative, just help us to allow encoding text labels while assigning the right emotional tone. The other one is we import classification report or confusion matrix from the matrix. Okay, this is just to help us evaluate how well the model performs. It's not important. Then multiprotect will just help us to prot. So for me, what I usually like when I go into this part of now reading or now viewing or uploading the data that I'll be using, I like to put my files in one folder, so it is easier than to write very long directories to be able to access it. So for me, just encoded some errors with my encoding, because when I use the UTF, is it the UFT or the UTF? Whatever I use that UTF-8 encoding, it was not displaying, it was bringing some error, so I just used to use Latin 1. So before we continue, this is my data which I used, and as you can see, this is the text, this is the sentiment, the other are not very important. So for example, you see it is already labeled, like the last session of the day, somehow that is neutral. You cannot get the right emotional tone of the text. So really exciting, of course, is positive. For a negative one, you say the realization. Yeah, so yeah, it's such a shame. That is negative. So basically, it's like I'm going to move have a have a model or train a model on what is the emotional tone of this text, and then we shall now, after that, now give it some random text, and then it will be able to classify for us. And then yeah, so without much ado, I'm just going to go through this so faster. So you see it is the same data that we have seen in my Excel. So the second, after loading, the other important thing is this whatever thing called feature engineering. And in this feature engineering, sometimes you find there's some rows with empty values. So what we just did here is just to ensure that text column which contain the input sentences has no missing values and is stored as string. So this ensures that there's no empty values, otherwise it will fill with a null. Then this will ensure that it is a string. So that's why you see this the quotation. So the other thing, we have to define the features and the target. So X, I give it as my text. This is a column name called text. The Y, I give them as the sentiment. So the other step is to encode labels, and this way we are using now the label encoder. And here basically is to convert the textual data to numerical data. Yeah, as I've commented here, convert textual categorical data into numerical data using the TF-ID vectorizer feature. Yeah, so that is it. So the next step, uh, the next step that we have here is now actually um, splitting our data into train test and splitting into train and test data. So here you see the test size data we're just taking 20% of it. Yeah, so the train data will be the remaining 80. So the random state, this basically ensures the reproducibility of our model. Mm, yeah, so as we con- so uh, the logistic regression, uh, this one, it basically creates an instant of logistic regression classifier from scikit-learn. This logistic regression is a kind of supervised learning algorithm used for classification tasks. And I can add that despite the name, it is not used for predicting numerical values, but rather classifying items into categories. And right now, our categories are the positive, negative, and neutral. Yeah, so the model.fit, um, this one now, it trains our model using the training data, the X train and the Y train. And during the training, the model will learn the relationship between the word patterns in the text and the corresponding sentiment classes. As I showed you here, now the model will learn now the relationship between this. Why this? Sorry for that. Like, why this negative and why this positive? Yeah. So the next thing is now the prediction. And before this, I can add something that after this dot fit, this method, we are saying that once model is trained, it has learned to classify new unseen text into sentiments categories based on the patterns it detected in the training data. As now we can see down here in the predict. Now here it will not try to predict the 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 new input text as positive, negative, and etc. Uh, yeah, so already now the mode is good, but now we just wanted to see whether now is our model okay, and I want to run my code. We want to give it some data and see if it will perform. Sometimes it takes wrong, but I don't know. I don't know. Hmm. Sometimes it may take long, but yeah, good to take long. So back to our yeah. Now the mode is learning. Now here the model is predicting. Yeah, and you can see. Yeah, we can see it has learned. Maybe let me say something good. Like here, I can just change this statement to be it is bad. I wasn't. I wasn't satisfied. Yeah, and then we can see whether our model, the feedback of our model. Yeah, So yeah, let's see the output. Yeah, we run our code. Yeah, you see, yeah, our model is right. So we say it is bad. I wasn't satisfied with the service. The predict is negative. So our model, we have already trained our model, and it has already learned the patterns and the relationship between our data, the text, and the sentiment, and it can now predict on its own uh, the emotional tone of the of the of the the text. Yeah, so that is it. Um, and the application part of it is that here in this code, I had given it some new yeah, here down here, and give it some new data, some new inputs, and it had to classify for me, as you can see, and calculate. Yeah, so let me show you. Yeah, it's a document that I called statist. Yeah, whatever. Yeah, it was to test now from a new model. This is the same model actually, and from this you see it already had ID in the tweet, but we are not classified. Maybe I can check for it. Sorry for that. I can check for it. Not that is over here. This one here. And as you can see, our document just contained the ID and the tweets and nothing else. So I just wanted now to to classify this, whether to be positive or negative. And then that is after feeding it this document here containing our data. You see from the analytics or from the insight that I got is that the neutral 50%, positive 50%. In I also visualize that using Matplotlib, and it was nice in the Z of it. So you can like and subscribe. Any question, remember to type in the comment below, and I will drop my GitHub link so you can download the codes and try to learn them, to run them yourself, and that is the end of it. So thank you guys, thank you for